Now we're going to talk about DNS. Don't know why I have headphones on. We're going to talk about DNS, and so that is domain name service or server or system, depending upon the context what we're talking about. If we're talking about the machine itself, that's the domain name server. If we're talking about the service running on that physical box, it's the domain name service. And if we're talking about DNS in general, it's the domain name system. So you'll see name or naming, any of those combinations, domain name or naming, system, service, or server, any of those are going to be fine when we talk about acronyms, because they're all correct in one way or another, depending upon what we're talking about. All right. So I'm going to split this into two. You already knew that because you probably looked at that. I'm going to split this into two. We're going to talk about DNS as its service functionality, and then we're going to talk about the DNS ICANN top-level domain background, so you have some sense of what's going on with that. All right. So when we talked about wins, we talked about wins was converting or resolving NetBIOS names to IP, and DNS is a fully qualified domain name, which I talked a little bit about last time, to an IP. So a fully qualified domain name has four different compartments. It has a host name, typically that's www. It has the domain name, Microsoft. It has the DNS suffix, .com. We'll call those top-level domains TLDs, and we'll talk about that in the next section. And then if you haven't watched the DNS video, which I have right here, DNS Explained, DNS Made Easy, nice little 6-minute video, talks about the root there. And actually we can go where to find the root name server. So that is the dot that's at the very end. So that we talked about before, originally long ago you had to put the dot in, and then it became optional, and then the browser did it automatically, and then we did the same thing with the www. If you don't put anything in the host, it assumes it's a website that it's looking for. So we go back to here, and we actually have the fourth part here, and this we don't have to do anymore. So typically when we're talking about a fully qualified domain name, we're talking about host, domain, and suffix. And 99.9% of the stuff that we're going to do is only going to have those three parts, because we don't worry about the root anymore. So the issue for, or the functionality of DNS is to map a fully qualified domain name to an IP address, and it translates that. Actually, the DNS Made Easy video goes through that. Now I'm going to go really quickly. Let's assume that we were sitting in the classroom and we are actually under a country code, and we'll talk about that in the next section. But .us is a country code. There's a state code inside that, so there is a secondary Illinois, so we have il.us, and then we had community colleges were a subdivision under states, and then we had all of the community colleges. So our original URL was lakeland.cc.il.us. So it goes from the tree is upside down, so the root is at the very top, and we start at the bottom, and lakeland.cc.il.us, and we work our way up. Dot, I guess, at the very top for the root. So we used that for a long time, and then it became cool because when we got a little further on, they actually registered lakelandcollege.edu, and we had there were some legitimate reasons for it. There were some services like Microsoft. If you were going to prove you were a student, you had to have a .edu address, and so we had lakelandcollege.edu and we had lakeland.cc.il.us, and we could use them both, and DNS actually would work either way. And actually, my email address is srine@lakeland.cc.il.us or srine@lakelandcollege.edu. They both work. Our DNS entries are actually the same. They'll resolve to the same thing. At a certain point, it became cool to use lakelandcollege.edu, and the college wanted everybody to do that. So our official business cards and all of our documentation switched over to lakelandcollege.edu, and there was actually a legal fight over that at some point, because there's a Lakeland College in Ohio and there's also a Lakeland College in Florida, and they actually sued us, which was it was weird. We had gone out and basically squatted on every variation of Lakeland College that we could get. We were there first, and then they sued us because we took them all. We took .com, .edu, .int, .org. I think we took all of them, which they were just trying to do exactly that. They were trying to squat on them so the other schools couldn't use them. And there was some type of resolution to that. I'm not sure what it is. Anyway, let's say that we're on and I'm going to use lakelandcollege.edu just because it's a little bit simpler in this. But let's say that we're sitting in the classroom and we want to go to www.google.com. Now, we have to look at this from the root. We start off with .com. So we have the root, and then and we're going to talk about this in the next section. The top level domains .com and .edu are two of the original. And there's a question. There's 7 of the original top level domains. Can you name them? Nobody can, because we don't use most of them. Let's see if I can from memory. So .com, .org, .edu, .mil for military, .int for international. I have 5 of them. .net, .edu, .org, .mil, .gov. Okay, so those were the original 7. Now, if you had all those stacked out, the percentage of total web traffic being used was like 98% and 1% and maybe let's say 0.5% and 0.5% or 1%, and then these are like 0.1 and 0.05 and 0.4, something like that. Let's say this is 0.8. I'm just making these numbers up, and let's say this is 1.5. We'll make this like a 97. All right, so almost all of the traffic is going to .com, which for a long time has been a problem. And original naming, you could just scott.com. I could just grab that, but now today I'd have to be like scott whatever I'm doing.com to be able to get very specific. Anyway, that ended up being an issue. So got sidetracked there, sorry. So we are sitting in the classroom and we're trying to resolve google.com. So we look at the .com and say, we're actually in .edu, so we have to go to the root and we have to find out where the .coms are. Now, we'll look at this. Actually, I'll just look at it now. There is a listing. There is a root file that exists. The ICANN servers / government servers. This is the root hint list of A through M, the different servers that are on the internet, the 13 of them on the internet that actually have the listing of the IP addresses of all of these guys. So this is the root hints file, actually points to all of these individually. this file is actually located on your machine. And Bill Warfel, the NetAdmin, and I were tooling around one day. This was a long time ago, and we said, I wonder what happens when this file gets deleted, because if this file gets deleted, we don't know where the other top-level domains are, and DNS resolution would break. We said, I don't know. So we were on a machine, and he logged in as an admin, and he deleted this file. And then he rebooted the machine, and it rebuilt it. So Microsoft systems will automatically, dynamically rebuild this file to make sure you have it, which, it's a good thing, because you need to have that, otherwise DNS breaks. The problem is, and I'll allude to that in the next section, the DNS setup that we have is from the US government and ICANN, and isn't the only DNS on the planet, but it's the only one that's recognized. So it's really weird that they're called alternate DNS routes. If you're pointing to an alternate DNS route, it doesn't work using this. These only point to the officially government sanctioned routes. All right, so that's query goes to the root, and then .com, and then in this resolution, I'm google.com from someone at Microsoft, and I just flipped around, and I actually changed that to be on our campus. So we would go from our DNS server, we'd go to the root, we find the .coms, we'd say, hey, .com server, can you tell me where the Google DNS server is? And I would get an IP back from that, and then I would do a unicast, basically, question for the Google server to ask it what the www host is on their network, and then I would get that back. So it's actually a process of a few different queries that goes lightning fast, and the DNS Made Easy video does a pretty good general job of it. We don't need to know all the specifics. In server class, we'll talk about DNS resolution, the iterative and recursive queries and the way that they work, and we'll talk about authoritative DNS servers and setting up the different types of systems. So basically, we'll go through and we'll build a DNS server and we'll configure it, and you'll have to know some more of the stuff. But at this point, we just need to know what DNS is. So basically, I go out and I find it. I ask a bunch of different servers. I find the answer, and it either exists and I get an answer back, or it doesn't exist and I get an error. Then that actually gets cached into RAM on the DNS server, which is one of the reasons why you don't want to reboot your servers, because there's a lot of, and it ages out, but still their answers, once one person goes to google.com, I don't have to go back because I remember it. That list is a fairly static list. It does change, but in general, we want things to stay the same. Lakeland changed its IP address of the web page, and it took about 2 months to flush things out, and because the different servers remember it and keep it in their cache, depending upon the length of the cache of all the people in the chain, 2 months later, we were still, sometimes from different places, you'd still hit the old page on an old box versus the new page on the new box. So we really want that to be pretty much a locked in static list, because it's a pain in the butt to change. So that being said, when you set up your DNS address and you register it, you really want to keep that on the same box. I'm not sure what the logic was for moving that to a different IP address instead of having, they wanted to have an old site and a new site, and they wanted them up at the same time, so we had to have resolution. So like the old site is good until like Thursday night, and then Friday morning the new site takes over. I think that was the intention that they wanted, but it was a huge pain technically to do because of the way DNS works. All right. And we have a host file. Now, I have pulled up my host file, which is right there. So this is actually off this is the host file, the default host file off a Windows 10 box. Yes, this is an updated new Windows 10 updated installation. This is what it looks like, and it is really old, and it looks just like it did back in NT when I first started teaching all of this in 97, 98. All right, so anything here that has, let me see if I can zoom in. Okay, anything that has a pound symbol is a comment, and it word wraps just because of the way this is, but this is entirely commented out. So it does give you an example here, and the example gives you an IP address and then its host name here, localhost. We know that 127.0.0.1. This is the IP version. This is the IP version 6 version of localhost, and we'll talk about that when we talk about IPv6, which I don't have in the schedule. I'm gonna have to squeeze IPv6 in there. So we have an IP address, and then we have a fully qualified domain name without the dot for that. This is almost always blank, but there are two times that I've seen there are three scenarios potentially you could have. If you didn't have a DNS server, you could build this as a static file. Now what happens is when I type in whatever I type in and I hit enter, the machine will look into RAM to see whether I already know what this, I've already been there. So is my DNS cache local, DNS cache in RAM already record this? So it'll look down there and see if you've already been there. So when you go there the first time, if it's a unique address you've never seen before and your DNS server has never seen it before, it may take a second or two to resolve, and then after that it should be instantaneous because it pulls it from RAM. So it looks there. If it doesn't find it there, then it looks to this file, this host file. And if it finds it here, you're done. If it doesn't find it here, then it goes and requests of a DNS server, and then DNS does the full resolution, and it finds the answer, it doesn't. So the times when you'll have it is, I don't have a DNS server and I need to do this, which is a bad idea because DNS is not that hard to set up. In server class, we'll do it in a lab, and it'll take to set a simple one up. I could probably, if I have the server already going and I need DNS, I could probably do 10-15 minutes, and I can have my own. Now I can point it to 8.8.8.8 is Google's DNS, and there's a 1.1.1.1, and I forget who controls 1.1.1.1. I should know that. But anyway, I usually use Google's 8.8.8.8, and the alternate is 8.8.4.4 can be your DNS, and they will take care of that for you. If you have Consolidated, Consolidated has this rule that you will use Consolidated's DNS. And one of the reasons why, if I use Consolidated's DNS, they will be doing the resolution for me, and they will know all the places that I go. That's good data that they can sell and other people will pay for. So if someone uses if you use someone's DNS server, then they can track where you go, and they can then sell your data. Anyway, it would be fine, except that Consolidated's DNS server is not the most reliable thing. So the internet will be good, but you won't be able to get to web pages because their DNS server is down. And I have a couple clients that have Consolidated service, and to fix it, I go in and I change it to either 8.8.8.8 or 1.1.1.1 or anything else. You change it to any other legitimate, standardized, redundant DNS server, and it works fine. And then the next time the Consolidated technician comes out to visit them. They look, they're supposed to look through, oh, your DNS is wrong, and they change it back. So then I get another call, the internet's out. I'm like, it shouldn't be. And I look and it's somebody set it back to Consolidate, and Consolidate's been out. So anyway, that happens occasionally, and we can do a ping because I only need DNS when I have a fully qualified domain name and I'm using an IP tool or I'm trying to browse. If I have the IP address, I don't need DNS. So DNS can be out and I can still ping an IP address, and that 8888 ends up being a really good one. So your internet is out, you ping 8888 and it comes back positive, which we'll do when we do IP tools, comes back as it's fine. I know the internet's good, it's just DNS is out, and we'll do that when we do testing. So not having a DNS server, but that's really cheap because I can just point to somebody else's DNS. We used to have it where schools would use it. They would not have a DNS server, and your local machine would not be pointed to it. Your local PC wouldn't be pointed to DNS, so it would have to use this. So then they would go to all the teachers and they would get a list of Crayola.com and SesameStreet.com and Lego.com and all the places that we want. Kind of it's a whitelist. They have a whitelist of websites that you can go to. We would look up their associated IP addresses and we would populate this host file. We basically just take out the pound symbol and put those in, and this is a comment, we wouldn't need that, but I mean, if it's Crayola.com, you know where it is. But we'd populate this with those, and those are the websites that I could go to, and if it wasn't in this list, you couldn't go there. So we had early on, this got used because now I don't have to block addresses because I'm whitelisting. Blacklisting is blocking things. You allow everything, but then you block a few. Whitelisting is you allow nothing, and you just have this short list of ones that can get out. So kids figured out that if they had a list of sites you weren't allowed to go to and their associated IP addresses, you could just type this IP address in instead of the fully qualified domain name. If you type the IP address in, you could get there because DNS wasn't blocking you from it. It just the host file, the one you wanted to get to wasn't in the host file and you couldn't get there. But if you knew the IP address, you could. So you'd have like fifth graders who would be carrying around these cheat sheets with URLs and IP addresses, and then they type them in and look them up. So there was an easy way to get around that. The other thing, two other things that you'll see, and this is kind of rare, but malware occasionally will infect this host file. Now, if I'm going to change this host file, this is read-only and system, so I have to change that so it's not read-only and it's not system. And then I have to do it as an admin, and I change it, and then after I modify the thing, I'll put it back. So modifying the host file, you got to jump through a couple hoops to be able to get it done. But malware occasionally will do that, and the really, I won't say great ones, but from my standpoint as a security instructor, I think it's pretty fantastic. The malware would infect the machine, and then it would put down here, it would put the updater for Microsoft and the updater for Malwarebytes and the updater for McAfee and the updater for whatever, all of Norton, all of those places that you would go to fix this, to get a signature file, they would map them all to 127.0.0.1. So when I went to the software went to update to the newest signature file, it would look here first because it always looks in RAM first, then it looks to the host file, and then it goes to DNS. So it would look into this host file, and it would find that Norton's updater's IP address is 127.0.0.1, which is the loopback address, which is me. That's the pronoun me. So it would look to my machine and say, oh, can't do that. And so your machine would never update. So you'd get infected, and then because it poisoned your host file, your machine wouldn't be able to go out and update to find out what the patch was to be able to clear. when I first saw this, when I read about it, and then we had one of our instructors brought a machine in and it was actually infected with this. And it was, 20, 30 different, like anything you could ever want was in this list. So you actually had to type in the IP address to get around this. So you didn't use a DNS resolution to go to the website to be able to pull anything down. It was kind of genius. Now, even better than that, we had one of the machines in the lab. This has actually happened twice. Spybot Search and Destroy, I believe, is the tool that did it. And Spybot Search and Destroy actually poisoned this file as well. But it did it for good and not evil. So this file should be this long. It should be a page long, less than a page long, only a couple sample things. We were doing there was some funky going on with the machine, and I looked at and it should be 1K too. I looked at the host file and it was like 127K or something like that, which is ginormous, So I open it up and it's, the scroll box here is just a little bitty thing. And, at first I'm like, this is really, really bad. But I look at it and everything in here is a malware site or potential malware site, and every IP address is actually mapped back to 127.0.0.1. So what they've done, Spybot Search and Destroy poisoned the host file so that if malware tried to infect you, if you clicked on a link that said go to some Russian site that was going to infect you, it would look here before it went to DNS, and so it would go to the loopback address, and you get a 404 error that it doesn't exist. So I thought that was rather ingenious that it actually used the host file to poison bad places instead of the other way around. The malware was poisoning the host file so you couldn't get to all the good places. This was the opposite. So you should be aware of the host file and where it is. Now, it is C Windows, and this is the same on every machine, every Windows machine. Windows System 32 drivers. It does not make any sense that it's in the drivers folder, and then it is in the etc folder, and then it's just hosts. It doesn't have an extension. So if we go to that folder, which I have right there, so C Windows System 32 drivers, etc, we see there's the host file, there's the LM. Sorry, multiple screens. I was looking at the wrong screen. So C Windows System 32 drivers, etc. Same place all the time. There's the host file and it's 1K. There's the LM host file, and we've got protocols and services, which I have not used any of those. I haven't even used the LM host file, but the host file becomes important. You do need to know where it is, and you need to look it up and keep an eye on it, because if it gets tampered with, that is going to basically step between you and DNS resolution. So whenever DNS resolution is really funky and you're getting something really weird that you shouldn't, look at your host file, make sure. And one thing you can do, usually you can just delete it. If there's something wrong with it, just delete it and reboot your machine. The root hints file will auto-populate and the host file will auto-populate. So it'll just revert to what we just saw right there. Okay, so that's the location of it and what it is. Now, we got one other thing. I'm going to go back here. So we had DNS and we had WINS. Whoops. We had DNS and we have WINS, and we also had the hosts file and the LM hosts file. So early on, I had a hard time keeping these straight, and I finally figured out that if you put these two in alpha order and put these two in alpha order, they actually line up. So DNS goes before WINS and host goes before LM hosts, and if you do that, the mapping is the same. And since I figured that out, I haven't confused them or mixed them up. You just got to remember what the file names are. DNS is also shorter than WINS, and host is shorter than LM host. So, those visual things. This is one of the things that when we talk about doing a dump at the end. This is one of the things that I think early on for the Net Plus that I put on my brain dump when I got into the test and got my piece of paper and was able to write things down. I wanted to not get those confused, because you will get a question, which of the following static text files? So these are both static text files, and these are services. So which static text file goes with which service? You'll need to understand that and know that. Okay, so we're at about 30 minutes, a little longer than I was hoping for, but I'm going to stop here, and then I'll have hopefully a shorter video about top-level domains and ICANN and kind of the background of that, and then we'll go on to IP tools.